While in school, our education began with the introduction of alphabets and numbers, and the two were taught to us as two separate subjects. What if we told you that we could help you understand the world of numbers through alphabets? Don't believe us? Presenting the A2Z of Mathematics. Come, let's learn. Welcome to yet another session of the A2Z of Mathematics. So far we've covered A, B and C of Maths. Today we talk about the D of Maths. Numbers reveal the outcomes of counting and measurements. The extent, magnitude or amount of something are expressed through numbers. D here stands for decimal numbers. Decimal is derived from the Latin word decima, which means a tenth part. It is also called Hindu-Arabic or base 10 number system. The decimal system is used extensively in education and business. Just like we have alphabets in language, the 10 mathematical symbols 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 are referred to as digits. Numerals and numbers are created with digits. Now let's understand what numerals and numbers are. Say for instance, the numeral 520 signifies only magnitude, whereas the number, which is rupees 520, signifies magnitudes as well as units. Numbers are often misunderstood. The standard of education in maths today signifies an absence of truly understanding numbers in school math. 6 plus 5 is simply and always will be 11 in school maths, as 6 and 5 are not considered beyond numerals. Whereas in real life we come across 6 and 5 as numbers whose sum is seldom 11. For example, if you add 6 rupees and 5 paise, the answer is not 11 rupees or 11 paise. All decimal numbers do not have a point which separates the whole part from the fractional part. The numbers 12, 37, 1029 are also decimal numbers, as are 32.5, 1147.689 and 1.75. In some countries, a comma is often used instead of a point to separate the whole part from the fractional part. The decimal number system is almost a standard and the most prevalent of all number systems that we encounter daily. It is also a simple and convenient positional system to write down numbers. For example, 3,57,892 and 4,57,992 differ from each other only at two places. And these differences can easily be expressed as of magnitude 1 lakh, wherein we see the difference between 3 and 4, and 100, wherein we see the difference between 9 and 8. The decimal numbers are also very easy to apply operations such as addition, subtraction, and multiplication. There are many other systems used to express numbers. Apart from decimal numbers, some of the other number systems are octal and hexadecimal systems. In everyday life, we work with binary for computers, dozen, and sexagesimal, which has 60 for its base. For instance, 1 minute is equals to 60 seconds. The decimal numbers we employ are made of distinct kinds of packets of quantity: ones, tens, hundreds, thousands, and so on. And a number can have only up to 9 packets of each kind. Each position or place in a number is a unique sized packet determined by its place. For instance, the 4 from left in 457 is made of hundreds, the 5 is made of tens, and 7 is made of ones. Every number is unique and it can be written in only one way. Let's try and understand the idea of 10. Understanding 10 is of utmost importance to be adept with decimal numbers. 10 is 1 10 and 0 units. 79 is 7 tens and 9 units. 100 is 10 tens and 0 units. 1007 is 100 tens and 7 units. And 10,005 is 1000 tens and 5 units. We also have other names for 10 tens, which we also call 100, 100 tens, also known as thousands, and 1000 tens, known as 10,000s, and so on. The idea of 0. 0 is a digit and a quantity. For example, 5 oranges subtracted by 5 oranges is equals to 0 oranges and not just 0. 0 is often mistakenly considered equivalent to nothing, which it is not. In the positional number system, it is a placeholder for the absent packets of quantities. For instance, 40,007 cannot be written unless 0 is used to show 0 thousands, 0 hundreds, and 0 tens. Regrouping of packets. Regrouping is the process of making groups of tens when carrying out operations like addition and subtraction with 2-digit or larger numbers. To regroup means to rearrange packets in place value to perform an operation. The principle of carry. Though primarily associated with regrouping for an addition operation, the principle of carry is property of numbers and not exclusive to the addition operation. The sum of numbers at a position or place cannot have more than 9 packets. When the sum of packets at a position exceeds 9, then the sum of packets is regrouped and a packet of 10 is carried over to the next higher position or place. We now talk about the principle of borrow. Though primarily associated with regrouping for subtraction operation, the principle of borrow is a property of numbers and not exclusive to subtraction operation. The subtraction of numbers at a position or place cannot leave less than 0 packet. When the subtraction of packets at a place or position falls short of 0, 10 is borrowed from a higher place or position. We then subtract from right to left as bigger packets are on the left. The long multiplication method is based on the power of 0. For example, 20,000 multiplied by 400 needs 2 into 4 multiplication to get 80 lakhs. The zeros trailing 2, that is 20,000, and 4, that is 400, can be conveniently ignored. In 234 multiplied by 78, we only multiply 2 and 7 and not 270. In the long division method, the trailing zeros are assumed. For example, in 430 divided by 6, we divide 43 by 6 in step 1 to get 7. And the trailing zero is assumed and it becomes 70. Thus, we don't divide 430 but just 43. Indeed, 430 by 6 is 71 and the remainder is 4. So that brings us to the end of the D of Maths. Let us go back and do a quick recap. So A stands for approximation, B for bounty, C for calibration, and D for decimal numbers.